Previous problems are related with the algebraic functions and functions are having the set of ranges that is defined in the some range, left limit, right limit. But in this cos x by x, sin x by x, tan x by x, e power x by x, that relations are there. But again, you can recall the formulas. Do you know limit x tends to 0, sin x by x equal to 1. Limit x tends to 0, cos x equal to 1. Limit x tends to 0, tan x by x equal to 1. Limit x tends to 0, e power x minus
తెలుసండి.
1 by x equal to 1. These are formulas. Okay. These formulas are related to these problems. That is the main thing. But in this, which is suitable? If the denominator is reduces to 0 when we can apply the limit value, then we can ignore that and simplify. Why? Because 1 by 0 means it's infinity. The limit value is a some value that is a it's a real value only. So it's not infinity, the limit value. In that case, we can use the suitable formulas. For the second problem, already first one is over. Then when you can substitute x equal to 1, it is 3 by 4 is the answer. 1, 2 plus 1 is 3. 3 minus 4 plus 5. 8 minus 4 is 4. So the second solution is here, carefully you observe, limit x tends to pi by 2 cos x by x minus pi by 2. If you can apply in the place of x pi by 2, then it can be reduces to 0. The denominator part is 0. So we cannot substitute. In that case, we can take limit x minus a, that is x minus pi by 2 tends to 0. In that case, x can be written as pi by 2 minus x. Then you are getting the same value. Sine of pi by 2 minus x by x minus pi by 2. Just so you can write it. X minus pi by 2 tends to 0. Here x tends to pi by 2. When you are substituting x equal to pi by 2, then cos pi by 2 value is 0. If x minus pi by 2 tends to 0, then pi by 2 minus x value is also 0. Okay. So here x tends to pi by 2 means from this x minus pi by 2 tends to 0. You can, and we know that sine 90 minus x is the cos x value. So you can change the limit value and the function. Why? Because in the numerator and the denominator, both will be 0 when we can substitute the value of x. Okay. In that case, we can change it. So it is equal to limit x minus pi by 2 tends to 0 sine of pi by 2 minus x by, in the denominator minus is taking common, pi by 2 minus x. This is minus limit x minus pi by 2 tends to 0 sine of pi by 2 minus x by pi by 2 minus x. It is in the form of x tends to 0. Whatever the value, this value, it is equal to this one. Okay. So this is equal to minus 1. Why? Because limit x tends to 0 sine x by x equal to 1. So limit x minus pi by 2 tends to 0 sine of pi by 2 minus x by pi by 2 minus x is equal to 1. This is minus of 1 is equal to minus 1. Therefore, limit x tends to pi by 2 cos x by x minus pi by 2 equal to minus 1 is the answer. The third problem is limit x tends to 0 sine AX by X cos X. Okay. Here we know that again we can apply the form of, we can use the form of limit x tends to 0, sine AX by A is equal to 1. Sine AX by AX equal to 1. It is the formula. And one more formula, limit x tends to 0, cos x is equal to 1. Limit x tends to 0, f of x by g of x is equal to limit x tends to 0, f of x by limit x tends to 0, g of x. These are the basic formulas. We use these relations. Okay. So here in the denominator, write separately first one. Limit x tends to 0. Sine has denominator x. Cos for cos is no need. Limit x tends to 0, 1 by cos x. Here we should multiply and divide with a. This a is a constant right outside. A limit x tends to 0, sine ax by ax into limit x tends to 0, cos x value is 1. So 1 by 1. It is equal to a into 1 into 1. It is limit x tends to 0, sine ax by x cos x is equal to a. This is the solution. Next problem, fourth solution. Limit x tends to 1, sine of x minus 1 by x square minus 1. Immediately you get idea. We know that limit x tends to 0, sine x by x is equal to 1. Here x tends to 1 is there. You should change into the limit value as the second problem. Limit x minus 1 tends to 0, sine of x minus 1 by x minus 1 is equal to 1. This is the changing of the function. Okay. Here, x square minus 1 can be written as, it is in the form of a square minus b square can be written as the factors of x minus 1 into x plus 1. So now you can change into it is limit x minus 1 tends to 0, sine of x minus 1 by x minus 1 into x plus 1. Okay. So in this case, you can write it as, that is our idea. If x tends to 0 is there, then we have the relation sine x by x equal to 1. If x tends to 1, then 1 minus 1 is 0. Then in that case also that should be 1. So for that idea, I can make into this relation. But again, you can write it as limit x tends to 1, sine of x minus 1 by x minus 1 into limit of x tends to 1 into 1 by x plus 1. Okay, now it is goes to the form of 1 and you can write in the place of x equal to 1 for the second factor, that is 1 by 1 plus 1. 1 into 1 by 2 is 1 by 2. Therefore, limit x tends to 1, sine of x minus 1 by x square minus 1 equal to 1 by 2. Next problem. Fifth one. Limit x tends to 0, sine of a plus bx minus sine of a minus bx by x equal to what is? Again, we can recall the formula. Sine of a plus b into, sine of a plus b minus sine of a minus b is equal to, if the minus is there, that is the 2 cos a sine b. Okay. Here in the place of a is there, b is, a is equal to small a, b equal to small bx. So you can write it as limit x tends to 0, 2 cos A sin bx by x. So it is equal to limit x tends to 0 2 cos A into limit x tends to 0 sin bx by x. Here sin having which function, then that is also in the same function in the denominator. So for that, we should multiply and divide with b. This b is a constant right outside, and this is also a constant value. 2 cos A into b into 1, that is equal to 2b cos A. Therefore, limit x tends to 0, sine of a plus bx minus sine of a minus bx by x equal to 2b cos A. Sixth problem, limit x tends to a tan of x minus a by x square minus a square, where a is not equal to 0. It is also limit x tends to a tan of x minus a. In the denominator, it can be written as into two factors, that is x minus a into x plus a. And we know that the form of limit x tends to 0 tan x by x equal to 1. When we can substitute 0, then it should be tan 0 is 0. In the similar way, limit x tends to a tan of x minus a by x minus a is also equal to 1. So here we can write it as limit for two factors. That is one for limit x tends to a tan of x minus a by x minus a. And one more factor is limit x tends to a 1 by x plus a. We know that this is equal to 1, that is 1. This for second factor, we can apply in the place of x equal to a, that is a plus a, 1 by 2a. It is the answer. Seventh solution, limit x tends to 0, e power 7x minus 1 by x. We know that the formula of limit x tends to 0, e power x minus 1 by x is equal to 1. By using this form, if exponential have which ratio, then that should be in the denominator. For that, we can take 7 for multiple and division. That is 7 into e power 7x minus 1 by 7x. 7 is a constant right outside. Limit x tends to 0, e power 7x minus 1 by 7x. It is equal to 7 into 1 is the 7. This is the solution of the seventh one. But these all are based on the basic formulas only. The eighth solution is limit x tends to 0, e power 3 plus x minus e power 3 by x. It is also suitable to above formula only. This can be written as limit x tends to 0, e power a plus b can be written as e power a into e power b. It should be 3 e power 3 into e power x minus e power 3 by x. It is equal to limit x tends to 0, e power 3 is taking common, e power x minus 1 by x. E power 3 is a constant right outside, limit x tends to 0, e power x minus 1 by x. It should be 1. The answer is e power 3 for the eighth solution. Again for ninth solution is limit x tends to 3, e power x minus e power 3 by x minus 3. Okay. For this, what we have the relation e ratio x minus 1 by x limit is equal to 1 when x tends to 0. Here, x minus 3 is there. So for that case, we should multiply and divide with e power 3. Or we should take the e power 3 is a common. That is limit x tends to 3. E power 3 is taking common. Then it should be e power minus 3 into e power x minus 1 by x minus 3. It is equal to e power 3 is a constant, right left side of the limit x tends to 3. E power a into e power b is e power a plus b, that is e power x minus 3 minus 1 by x minus 3. It is in the form of e power x minus 1 by x. So it should be e power 3 only. Why? Because it is equal to 1. Then limit x tends to 3, e power x minus e power 3 by x minus 3 equal to e power 3. It is the ninth solution. Limit x tends to 0, e power sin x minus 1 by x. See, again we can recall the formula. Limit x tends to 0, e power x minus 1 by x equal to 1. So here e ratio sin x is there. In that case, we should multiply and divide with sin x. Sin x e power sin x minus 1 by sin x into x. Here x is shifted to sin and sin x shifted to e ratio sin x minus 1. So that is limit x tends to 0 sin x by x into limit x tends to 0 e ratio sin x minus 1 by sin x. It is equal to 1 into 1 is equal to 1. Therefore, limit x tends to 0 e ratio sin x minus 1 by x is equal to 1. It will come in the JEE questions. See here, the second type of the questions in this, the numerators and denominators, we cannot differentiate, we cannot separate. Okay. In that case, what is the clue for this? Here, first, those are in the some fractions and polynomial form. First, we should find out the factors of the polynomial equation. If any factor would get the cancel or not, that is the first thing. If it is sin a sin x by x minus a means, in that case, we should transfer into the form of sin x by x form. Is it possible or not? That is the one clue. For cos ax also, we can write it as cos c minus cos d formula. 2 minus 2 sin c plus d by 2 sin c minus d by 2. We can apply in that way. Okay. That is the thing of how we get the idea for this type of the limits. The previous case, that should be different. Those are, we can separate as we can multiply numerator and denominator with the suitable function or the suitable constant. Then it can be reduced to the formula. But here, these are not can reduced into formula by the multiply and division. So in that case, how we can do that? The first solution is limit x tends to 1 into 2x minus 1 root x minus 1 by 2x square plus x minus 3. First, we can find the factors for the denominator. 2x square plus x minus 3. This 3 2s are 6. Then 2x square plus 3x minus 2x minus 3. Here x is common, 2x plus 3. In this minus 1 common, 2x plus 3. The factors are 2x plus 3 is the one factor and one more factor is x minus 1. Okay. Here it should be written as limit x tends to 1, 2x minus 1 into root x minus 1 by 2x square plus x minus 3 can be written as 2x plus 3 into x minus 1. Observe here when we can substitute in the place of x equal to 1, these two factors should be zeros. So, and here x minus 1 can be written as root x whole square minus 1 square. It can be right into the factors. One is root x minus 1, another one is root x plus 1. So that we get the idea for this solving the problem. That is limit x tends to 1, 2x minus 1 into root x minus 1 by 2x plus 3. Again, it can be written as root x minus 1 into root x plus 1. So these two are get cancelled. Then we have the terms of numerator 2x minus 1 in the denominator 2x plus 3 into root x plus 1. Now we can apply in the place of x equal to 1, then it should be 2 minus 1 by 2 plus 3 into 1 plus 1. It is equal to 1 by 2 plus 3 is 5 into 2. It is equal to 1 by 10. This is the answer. First, we should write x equal to 1. It goes to reduce to 0 or not. If it reduces to 0, then we can maximum to simplify to any suitable formula, make into non-zero form, 0 by 0 form. Okay, this is the way. For second solution, taking the problem limit x tends to a, x sine a minus a sine x by x minus a. If here x sine a is there, if we can add with a sine a minus a sine a, then these two are get cancelled. Why we are adding means here sine a is there, here also sine a is there. When we can taking common for sine a, we are getting x minus a. So x minus a will get cancelled. This is for the another way. Why? Because a is a constant, another one, the two terms in the sin x and sin a form. That can be expressed in the form of sin c minus sin d form. For that case, we can add and subtract with a sin a. Then it should be limit x tends to a. Next sin a is taking common. It is x minus a into sin a. Next minus a is taking common. It is sin x minus sin a by x minus a. Here write separately limit x tends to a, x minus a into sine a by x minus a minus a is a constant right outside. Limit x tends to a, sine x minus sine a by x minus a. Here these two are get cancelled. It is sine a is a constant. This is sine a only. Minus a, it is in the form of sin c minus sin d, that is equal to 2 cos c plus d by 2 sin c minus d by 2. The same form of the sine of a plus b minus sine of a minus b equal to 2 cos a sin b, how it is. If it is a single function, then we can change into that one. It is minus it's minus a into 2 cos x plus a by 2 sine x minus a by 2. When we can take the limit. Limit x tends to a. It is equal to sine a minus a. Limit x tends to a. 2 is also constant right outside. Cos of x plus a by 2. Write separate limits. Limit x tends to a, sine of, Here also the denominator is x minus a is there. This x minus a is distributed to sine function. Sine of x minus a by 2 by x minus a. In the denominator, you should multiply and divide with 2. So this is in the form of x minus a by 2. This is equal to sine a minus 2a. When we can take in the place of x equal to a plus a is 2a by 2, 2 get cancelled. That is cos of 2a by 2. This is the 1 by 2 is the constant right outside. Sine x by x, it's equal to 1. It's 2 cancel. Therefore, limit x tends to a, x sine a minus a sine x by x minus a equal to sine a minus, here also 2 cancel, a cos a. Sine a minus a cos a is the limit value of the given function. Limit x tends to 0, cos ax minus cos bx by x square. We know that cos c minus cos d formula is minus 2 sine c plus d by 2 sine c minus d by 2. Here we can apply the limit x tends to 0 minus 2 sine ax plus bx by 2 sine ax minus bx by 2 by x square. Right outside this minus 2, limit x tends to 0, sine of a plus b by 2 into x by x. Write separately, limit x tends to 0, sine of a minus b by 2 into x by x. X square can be written as x into x. Next here, what we want, x coefficient, what is there, that should be, we can multiply and divide a minus b by 2. Here also, a plus b by 2, here a plus b by 2. Then it should be minus 2 into a plus b by 2 is a constant right outside. The limit value of this is equal to 1 into a minus b by 2 is a constant right outside. This limit is equal to 0. Why? Because limit x tends to 0, sine ax by a is equal to 1. Whatever the value has x coefficient, that should be in the denominator also x coefficient. Okay. Here 1 2 get cancelled. It is equal to minus of a square minus b square by 2, or b square minus a square by 2 is the solution. Fourth one, you can take in the place of x equal to 2, it's 4, it's 2, it's 4 minus 1, it's root 2 minus 2. No one term is equal to 0, no one factor is 0 in the denominator also. These are constants, just you can write in the place of x equal to 2. If it is root 2 minus 2 is there, then you can rationalize root 2 plus 2 by root 2 plus 2. You get the simplification. That is the fourth one. You do the homework. And the fifth one, we know the form of limit of x tends to 0, log of 1 plus x by x is equal to 1. Here 5 is there, we can multiply and divide with 5. Then the answer is 5. Why? Because log of 1 plus x by x equal to 1. It is 5x by 5 is equal to 1. So it should be 5. The sixth one I can explain now. Sixth solution is limit x tends to 0, sine of pi cos square x by x square. Here cos square x can be written as by using of the identity sine square. Why? Because for sine only the denominator having x. Sine of pi into 1 minus sine square x by x square. It is equal to limit x tends to 0, sine of pi into 1 is pi minus pi sine square x by x square. We know that sine of pi minus theta equal to sine theta. So it is equal to limit x tends to 0, sine of pi sine square x by x square. Here we can write it as sine square x is there. So we should multiply and divide with pi sine square x. Sine of pi sine square x by pi sine square x into pi sine square x by x square. Here, sine of which term is there? The same term in the denominator. Now we can write separately. Limit x tends to 0, sine of pi sine square x by pi sine square x into limit x tends to 0, pi sine square x by x square. This is equal to 1 into pi is a constant right outside. Sine x whole square by x square is 1. It should be pi. Therefore, limit x tends to 0, sine of pi cos square x by x square equal to pi. Here, sine square x is nothing but sine x whole square. If it is whole square is there, here also x square is there. We can write it as sine x by x into sine x by x, it should be 1, or sine x whole square by x square is also 1. This is the sixth solution.